All right, so today's session is on data calculations in ARM. So we'll basically, the premise is that you have entered in your data, the assessments that you've taken in the field, but many times there are additional things we may want to do with that raw data. And so there's kind of a variety of options, a variety of choices in ARM. And so we just kind of want to highlight kind of at least the big hitters, the most common ones. So we'll kind of be working back and forth between some slides here to kind of summarize, provide an overview of the options, and then we'll switch over to ARM and show an example and show where you can get there, and just kind of back and forth throughout the hour here. So first one I want to highlight would be kind of calculations for subsample data. So if your assessment that you took has more than one data point at each plot, in ARM we call those subsamples. And so you can summarize those subsamples into a separate data column, and that might be an easier way to work with the data. And typically those types of calculations end up kind of summarizing your subsamples into just one value per plot based on the rating that had multiple values. So that's really what we have here. And so I had kind of three different examples of what you may want to do with those. The first one, just summarizing as far as whether you would want to take the average of the subsamples or the sum, depending on your assessment. If it's a yield of some sort, you may actually want to take the sum, so you have the total amount in your plot. In most other cases, you would want an average. And so you would use either the TAS or the TSS, and these are action codes. So if I go to ARM, most everything that we will be running today eventually gets funneled into the ARM action codes row in the assessment header. So for this example, I have our raw data here. With that, we had sampled 5 leaves, and so we have 5 data points for each plot. So what we can do is enter in the action codes field for a calculated column. You can put in these different action codes to create a new data column that has summarized one or more raw data columns. And in this case, we have 3 in brackets, which is referring to column number 3. And it's kind of highlighted on the screen as well. So you can see that the values that we have in column 4 are being generated from column 3. So the summarizing subsamples, average and sum, pretty basic. I would say even you might not necessarily need to use like the average in a lot of cases. If that's all you're going to do, when you look at the summarization within ARM, if you were to run the AOV means table, the default action is actually to average subsamples and then calculate treatment means from that. So unless you have another use for that, some of these options are maybe a little irrelevant as far as actually needing a separate column with that, if that's the only thing you're going to do to summarize. There are also incidence calculations, essentially to calculate a percentage of your subsample values that are either greater than 0 or greater than 1. So just depending on how the values are entered is, do you put in a 0 meaning none, or would you put in a 1 meaning none? And the difference is just which TIO or TII you would use. And so here in my case, in column number 4, I use the TIO. And so we can see that if we look at the data in column 3, for plot 102, I have a 10, 5, and 3 zeros. So the incidence is, we're really counting what is not 0. and I have 2 out of my 5 data points that are not 0, so we get a 40%. So that's really what that calculation defines. And again, just depending on the type of assessment, whether 0 is there's nothing there, or perhaps 1 is there's nothing there. That's the difference in those 2 calculations. And then finally, the third example for the subsamples is counting the number of subsample values within a specified range. And so that uses the TIN. So that can be pretty useful for a variety of purposes. And I have an example here. So I'm looking in data column 3, and I want to count up the number of subsample values in each plot that are between 50 and 100. I just arbitrarily chose that, but I can imagine quite a few circumstances where you would have a range that is significant in some fashion to that assessment. And this would be a good way to count up how many of the subsample values matter to whatever criteria that you may have. And so you can see, in our plot 102, all of these values are less than 50, so the count is 0. If we were to go to plot 104, however, there is an 80 and the rest do not match, so we end up with a 1. So that can be useful in some cases there too. So again, really just kind of taking those subsamples and creating another calculation from them, make it a little easier to utilize those values, especially if you have a lot of subsamples that you took. Now here's ways to simplify and summarize in a separate column, which then can be run through the AOV analysis and have results from that as well. So. The next category that I'd like to cover are control corrections. And essentially, we want to calculate efficacy relative to an untreated check. And in this case here, we're really referring to, when we say efficacy, really looking at a percent reduction. So really thinking that the check treatments are 0. You start at 0, and then the treated plots, what percent did they reduce the pest is really the assessment that we're assuming that what was taken, and these will calculate then depending on the different situation. And so here I kind of tried to summarize the different options, and there are quite a few there's different options, and then within each option there's different variations as well. So the first one is the Abbott's, and that really is the Abbott's calculation designed for an infestation assessment on a uniform population. And so that one seems fairly common, that you would run an Abbott's. However, there are several different versions of the Abbott that I tried to outline here. And so this first one is the action code is tab, and I would call that the classic Abbott. If you're just referring generally to Abbott, that's probably the one that you're looking at. And so again, we're trying to calculate relative to the check how the treatments performed, how much did they reduce the pest. And so we're calculating the percent from the check treatment in the same replicate. So we're really looking at just within replicate 1, how did what was the value in the check? What was the pressure in the check in this first replicate? And then what did this treatment perform? And we'll calculate the percentage of that performance relative to that. And we get a value per plot. So we're looking at each plot has a separate calculation. And this is really great when the check are reasonably consistent. So let's check what I have here. So for this example, again, it's pest severity, looking at just a disease of some sort. We took subsamples, but there certainly wouldn't have to be subsamples. and we used this tab. So that's the typical Abbott calculation here. And so you can see I've sorted by treatment right here. So all of the treatment 1 is our untreated check. And so you can see those are all 0. And by convention, they have to be 0. And then each value here now is calculated relative to the check in their own replicate. I'll see if I can visualize this at all. If I sort by replicate here, then you're really thinking of the calculations kind of in this group. And so when we calculate this 54%, we're really taking, okay, what did treatment 3 do? And since this is subsamples, you're really imagining the average of those values. How did that perform relative to how the check performed in this one replicate? And we get that value. Here, actually, let me do, I'm just going to toggle my view options quickly. So we view subsamples. We can just see the plot mean because I don't need to see each one of those values. Okay, so now we can actually see the plot mean here of those 10 values is a 2.3, whereas the check was a 5. So we did a little more than half. We reduced the pressure by a little more than half. So 54 would kind of make sense. Again, that's within this own replicate. And then in the next replicate that we have, all of the values are calculated relative to treatment 1, which is a 4.1 in this column. And those calculations are done within that replicate. So that works great when the check are consistent. So, okay, the across replicates, the check's about the same in all the replicates. So it's fair to calculate everything on their own individual replicate. That's great. Sometimes though, if the check was inconsistent as to what kind of pressure you had in the different replicates. If it really was uneven, maybe one replicate really got pounded or really almost nothing was there in the check, then you run into problems with just calculating in each rep, because now you're really messing with the entire rep, the whole calculation of the one replicate that might be quite a bit different than the other replicates. And so in that case, then we can turn to the U-tab transformation. And that, again, it's an Abbott's, but it's just a little bit different in that it's calculated against the mean of all of the checks. So across all of the replicates, we use that value to calculate the individual treatment performance. So again, kind of try to wash away any of that inconsistency in the checks. Let's just take the average across all the replicates and use that one value as reference when we're calculating our efficacy. So that would be the U tab. And really, again, to change that choice, it's simply a matter of what action code do you enter here. And so I've got tab, but if the case was we wanted to use U tab, it's actually just as easy of let's just change the action code in there. And now you can see that all of the values are now different. One thing to note, you may notice, well, we have a negative here. That's in the treatment 1. So that's, of course, looking at the different treatment values, since we're using the treatment mean or the check mean, you're going to have some plus and minuses. The rest of these are all positive, so it's not too bad of a situation. But if you do have a case where calculations are giving you negative values and that doesn't really make any sense, how could you have a negative? It really should just be 0. It really didn't do anything. Not that it actually, we really don't care that made it worse per se. If you wanted to kind of flatten this down to just be a 0, under the tools and transform, there is an option to limit calculated values to be positive. So that's a common question I see in support. So I just kind of wanted to highlight it here. If you don't like those negative values, depending on the data that you have, then that's an option, and that will, again, change the negatives to be positive. Not sure why my view just changed here, but so that's just a common option there. I'll just turn that back off just so we have our regular calculations, and we'll kind of update here. I must be somehow getting extra columns all of a sudden. I'm not sure what it's doing here. Oh, because I'm transforming. That's the problem. Is I'm continually applying a square root transformation. Let me just delete these data columns. So that's one option. Again, that's kind of referring to any calculation. So really anything we end up doing here today, you could have that type of option be applied. It is really referring to just in general all of our calculations here. All right, third option, real quickly. Again, we're still kind of talking about the Abbott's, but maybe we want to summarize on each treatment instead. So this previous calculation, you notice each plot had its own value. Really, you can even take the mean of each treatment and compare that to the mean of the check. And so now you really have one value for each treatment in that calculation. And so that would be the T-tab calculation. And so that basis really is per treatment now instead. And that's really if there's really wild variation across the whole trial, maybe that's an option to utilize this, or you like that one value, you kind of get the overall view of it. You'll notice when you use that, then you can't run any statistics because there is no variation in each treatment. Let me just real quickly, let's change this to a T-tab just to show that here now you'll see it's the same value for each treatment, because there really is only one calculation because you're using the treatment mean for each one of these. And so if you were to try to run this through the AOV analysis, it wouldn't make any sense. There's no variation, so there's no statistics. You just have, this value itself is really the statistic per se of what you saw in the raw data. So that's just a warning on that calculation. And so because of that, because you really only have the one value, there is a APC action code that will provide this value, the per treatment value. It will put this on your AOV report. So maybe you don't need a data column that has information. I just want to see it in my report. And so I actually have that here. I've added the APC to my raw data column. So now if I generate an AOV report here quickly, then we get our treatment means of the raw data, and then that APC value is displayed in parentheses in that data column. So now there's no need for a separate column of data on your report. You can just have that calculation here in your report instead. This might be a little easier to use than the T-tab. It's just simply the APC, automatic percent control, essentially just to have some extra information there on the reporting side of things instead. All right, let me change my view back before I forget that we did that. There we can see the individual values again. And one note with the control, the reference here, you would need to make sure to specify in the trial settings what treatment numbers are the untreated check. And so in your trial settings on the treatment tab, there's an option for the untreated treatments, and you just list the treatment numbers that you're untreated. If you had multiple, if maybe treatment 1 and treatment 7, you had more than one check in each replicate, that's just fine. You just enter 1 space 7 here, and then any of these calculations, ARM just automatically would use the average of those 2 treatments, and then do the same basis as we just discussed. It would just make sure to be pulling from both of those together. Few more options here on control corrections. That whole category here was really all Abbott's and the different ways you can run an Abbott's. There's a few other kind of named calculations that, just depending on your research and your industry, get used more often. Henderson-Tilton is one of those. That's really for infestation rating when your population is non-uniform. And actually, you are adjusting you adjust a post-treatment assessment after you've done your assessment or your treatment application. You take the rating and you actually adjust that rating for a pre-treatment assessment. And so actually, in this case, there's 2 different data columns that you specify, the pre and the post. And that then we get the Henderson-Tilton calculation as a result in that data column. Another option we have is the Schneider-O'Reilly, and that is for mortality ratings on a uniform population. So you would just use the code TSO for that one. If you don't want to memorize all of these codes, one thing I should have shown is that you can, in your data column, simply use the tools and transform. You maybe already saw this already. There's a section here of kind of built-in transformations. And here are some of those subsamples that we looked at first are right here. So instead of memorizing, was it TIO or TII, which one, doesn't matter. I can just pick one from the list. Same thing for the Abbott's. This would give us our tab, that first one, or Henderson-Tilton, Schneider-O'Reilly, a nice visual way to select that. And then you just tell ARM what column number you're converting and where you want to put it. And in this case, now you can see it will fill in the TSO code for us and give us that calculation. And it did also copy kind of all of the different header details into this column too, because assuming it is kind of really the same description, the same assessment, just calculated this time. So that's another, maybe easier way to do it instead of memorizing all these codes. But either way, you can also adjust the code as you get more used to throwing around those abbreviations and such. Either way works. All right, another option, kind of also here looking at your control calculations. You can also do a % of check. So previously we were kind of looking at the reduction, the check is 0, and how did the treatments do relative to that? Well, sometimes it's kind of the reverse, that you really want to calculate a % of the check. So your check treatment is 100 and everything else follows from that. And so it's kind of a parallel universe to those Abbott's. Just instead of 0%, the check is 100. And so kind of the correlation from Abbott's, where we did the tab, is the UPOC. So % of check was really the goal here. And so we're calculating the check, calculating a value from the check in the same replicate, just like we did before, per plot. Again, that's really great. When your check are consistent, you can definitely use that. If instead you want to do, kind of that T tab where we talked about looking at the mean of your treatment compared to the mean of the check, if there's a lot of variation in the study, maybe that's better to take that overall view of things, then the code would be the tupac. And I do want to just note that the @ sign does matter. If I toggle over to the tab, you'll notice tab does not have the @ sign. The rest of these do. You do, oops, just want to make sure that you include it where it is listed. To be honest, I don't know the difference. If there's a technical behind the scenes difference to ARM, perhaps, of what needs the @ sign and what doesn't. But in these cases, both of these do need the @ sign. And you can also obtain them from the action codes list. So we have a section here. It's listed under general calculations where you can find, for example, the UPOC, the percent of control, or the TUPOC, the percent of control per treatment. And typically what I do when I'm hunting for them, instead of scrolling, this action codes is quite a long list of options. You can just do a filter for in the description. This is on my wrong screen here. And so if you're looking for Abbott, you can say okay, and it'll track down all of the codes that have the term Abbott in their description. Or in our case here, we're looking at percent of control. So maybe I would search for, maybe I'll just search for of control, actually, knowing that that's kind of the trick. And sure enough, now we get these 4 options here to choose what we need. So a few different ways to get to the same end result of utilizing that action code, having that action code entered, which is the instructions for ARM to give us a calculation. And just like we saw with the T-tab, if you don't really want that one value, you don't need that extra column, it's just more of a summary, you can use APOC in the original column and get those very same calculations. So just the same as APC, this is APOC. So, percent check versus percent of check, abbreviation essentially. And just put that in your raw data column, and you'll have those percentages on your report. So that's it for the control calculations. The next set here, the next example, I should say, would be yield conversion. So let me first just set the stage here by going to ARM and looking at our example. So typically, kind of a typical setup for the yield would be that you have your assessment of your kind of the total amount, regardless of kind of how you weighed out the yield. In my case, I've got kilograms, the amount of the amount of kilograms here for the one plot. Let me just sort by plot. Then you may have moisture content that we can adjust for. And then we want to calculate a yield on a per area basis. Let's standardize that because of course, this plot size may be much different than another trial somewhere else. And so you really want to standardize that yield so we can really compare notes across different trials much easier. And so that's where the yield conversion comes in ARM. ARM can assist and create the calculation for you, taking the raw yield and converting it to a per area basis. And just to highlight, and we'll see this here in ARM real soon, but we can do a moisture adjustment or adjust to an overall dry moisture, and can even utilize the individual data column of moisture for each plot. We also support the harvested plot size if the harvested area differs per plot. Maybe it's just one plot that's different. Maybe each plot ended up having slightly different area for whatever reason. then you don't have to just use what's in trial settings, but you can actually put in a data column with the width and or length of the plots. And then ARM can plot by plot determine the area that was used in the yield, and then adjust the calculation accordingly. So here I have a yield conversion. You can see in the action code, it's called TY1. So the Y is kind of a transformed yield, and then with just the 1 is just kind of the arbitrary keeping track. If I did this multiple times in the trial, the next one would be TY2, etc. So I'm just going to go Tools and Convert Yield. This is how you would trigger and run the yield conversion. And in my case, it's partially filled in because I'm looking at a column that has been converted. But essentially, to start with, you would make note of what your current value is. What did we record our yield in? And then what basis do we want to calculate on? Here, it looks like I did tons per hectare. So that would be this option here, but you can see we have a wide variety of units to calculate to. Again, harvested plot size, this is what is entered in my trial settings. I can either adjust it here if need be, if all of the plots were the same, or again, you could use actually a data column and put in the different widths and lengths if needed. Then the moisture adjustment, here we're going to adjust to a 15%, and we should refer to data column number 7, has our moisture content for each individual plot. And so what we get is a yield conversion factor. So just based on your yield units and the plot size, then we get a conversion factor. And then it'll also do that'll do the moisture kind of after the fact there, since it is a per plot. And this conversion factor will be used in the calculation. And so then you just want to make sure you have chosen the original column with the raw yield, and then where you want, what data column number to put the data into, and however many decimals of accuracy you may want. In this case, it looks like I chose 2. So that gives us the converted yield information here in column 8. And it looks like in my example, I also have done a percent of check. So again, that UPOC, this R just means it's referring to the column right before it instead of specifying a particular column number. But we really did the APOC here, percent of control relative to the check. Since we're not too far removed, if I just sort by treatment, you can see that treatment 1 is all 100%. And then you can see how the yield, how much better was each treatment. So in this case, we wouldn't want it set to 0, but 100 makes sense. And now it's how much more did these treatments really provide? How much better yield did we get because of those treatments compared to the baseline check? So that's a nice demonstration of that calculation there. All right, so the next category are for rating scales. So these, and to be honest, this one I don't get a lot of questions in the support box from, but I know it's in there. So it's one of those, I'm not sure if it's not something that gets used often, or if it's a matter of people don't know it's there. So I thought, well, let's cover it here and get a sense, at least to show what's possible, whether it's just a rarity in the industry, or maybe people are doing it outside of ARM and don't realize that there's some kind of slick ways to utilize this. But essentially, it would be for assessments where you have a rating scale. If it's 1 to 5, 1 to 3, whatever scale that you're working on to assess the plot. What you can do and kind of the setup here to utilize these calculations would be that you create separate data columns to enter in kind of the tally of how many subsamples fit the in the certain scale or the class. So this is kind of a generalized, it's the number of, again, really probably for subsamples, you have multiple objects per plot that you're rating and giving a scale value to, how best to summarize all of that data. And so, maybe it's marketable fruit. I'll just use apples as a simple example that maybe we're taking a look at, 10 apples from a tree, and then we're gonna categorize them from 1 to 4. I think in this case we use, and so we'll just say that in plot 102 there were 2 apples that were in class 1. Maybe that's the worst class, we can't even use them. And then my number's hidden, but we can hop over and say that there was 5 apples that were in class 3. They look pretty good. They'll be great to be on the shelf. And then class 4, there's 1 apple that was in class 4. That's like the perfect apple. It looks glorious, and everyone would want to have it. So whatever the scale is, that would be the approach to setting this up. And so, of course, the more subsamples that you have, it's a little harder to enter in each individual value in a very long data column. So here instead, we can keep tally marks and put in those tally marks essentially for the data. So then once you have the data entered in there, now we have these calculations we can use to summarize that data into something then that will work really great with AOV, and we can draw some conclusions perhaps of how the treatment's fared. So we can do a pest severity, essentially kind of weight, a weighted summarization of those subsamples. And so, for example, we have the at EC14. So, really it's calculation, it's the EPO class from 1 to 4. So if you were doing a 1 to 2, if you were doing a 1 to 7, whatever it is, they got all the different combinations in the action codes list to utilize. But my example will just be 1 to 4. And really the calculation is everything in class 1, or your tally from class 1 gets a multiplier of 1. Your tally from class 2 gets a multiplier of 2. A tally of 3 gets a multiplier of 3. So you're kind of weighing, you're giving a weight to it. That, hey, the higher up it is on the scale, in my example, the more marketable the fruit is, the more value it has to us. And then we'll divide by the total number to give us an average. So that would be one example there. I guess it wouldn't work for the pest severity necessarily for my example of the apples. Maybe it would be in reverse, but you can also do an incidence calculation as well. And so here we have the disease. I guess I don't know what the abbreviation for this would be, but at DIP. And again, the 1 to 4 is just the scale that you're using. So those numbers may change. Essentially, we're going to say that very first class, I think I had it kind of opposite. The very first class is the best, actually, in this case. So we want to add up all of the other classes that had some sort of incidence to them. So that would be 2, 3, and 4. And then, of course, divide that by the total number we have everywhere, multiply it by 100 to get a percent. So my example of apples, I actually described that backwards, that class number 1 is the very best and maybe absolutely no issues with it at all. and then down to class 4 was the worst. It's totally not usable because of the disease or whatever pest that was present totally ruined that fruit. And so we want to know really how many things were affected by the pest, divide by the total, and give us the percent. And so that would kind of make sense with our severity as well then, that we're weighing the really affected ones more to give an idea of how much, how bad, how severe was the infection across that plot. So just to show that example here in ARM, I tried to bring screenshots so we kind of already saw this, but the number in class 1 all the way up to 4, again, those are essentially tally marks if you want to envision it that way. Really helpful for a lot of subsample work. Enter in the data with all those data columns, and now we can do some summarization. And so you can see the EC14 and the DIP14 to give the severity index, if you will, and then also the incidence percentage of what you have. And again, you'll see that those are, we have subsample data, but we don't have to enter each subsample point itself, really kind of summarizing the data here in ARM a bit. So on the flip side, maybe instead of using those tally marks, if you will, of entering the data, maybe you have a single column of data with subsamples. And the rating is that scale. So kind of the same thing, but just denoted differently. So maybe it just depends on, maybe it depends on how many subsamples or just your way of working, how things are done. You can have just one data column here with the individual subsample values and the scale value for each one of those subsamples. I can show that in ARM here. So I've got my pest severity, but it's a rating scale from 0 to 3. And so I've got 10 subsample values. So 10 apples we looked at, and each apple, I just wrote down the rating for each individual apple throughout the, I kind of stopped after the first few plots here for the example. But we can do the exact same calculation. So we can do a pest severity and a percent incidence. So really be the same idea, just a different way that the data was entered. So really great standardization practice. Right, from a sponsor's perspective, if you're sending out trials and you have, maybe people are doing entering in these subsamples a different way, you still have these calculations in the end. So regardless of how they took down the data, we can get this calculation. We can get a pest severity calculation and a percent incidence. And it really would be the same values you can compare across every trial, regardless of how they put in the data. So there's some power to that standardization practice. And again, you can see it's really the same calculation. Here, my examples lined up a little different, 0 to 4. It's really the same as a 1 to 5, just notation wise, whether it's a 1 or a 0, 2 and a 1, it's just slid over a little bit, but you really get the same calculation. We weigh each value as to how bad, how bad it is as you go, and then get the total across all of those. And then the same thing with the percent incidence. The class number 1, the very first class, is the best. It doesn't have any problems at all. So let's not count that one and count everything else, and then divide by the total to get an idea of how much, how many of the samples had some sort of pest, or whatever it is that you're rating. There's probably quite a variety of different situations where the same, scale approach takes place. But just to show that in ARM again, we just have slightly different calculation in the action codes here. So it's the disease severity from subsamples for the 0 to 4 scale. So that's what we used here, but it really is the same calculation, just the same as the percent incidence. It's just from subsamples instead of the tally marks of the last example. Really, we get the same calculation in the end. All right, last but definitely not least would be user formulas. So really, this is comparable to taking your data out to Excel and just being able to type in, in Excel, you just hit equal sign and start typing in your formula, and you get a calculated value. That's essentially what we can do in ARM as well with the data column worth of data. We can create any sort of calculation from that information. So to trigger that, let me go to my form here, and I've just got a raw data. This has got subsamples, so we can show a couple examples of that. But just in that data column under Tools, you select Transform. We saw all those calculations you can access here, but there's an option for User Formula. And now we just get kind of a blank canvas here of what is it we want to type in. So the most basic tips here, what you can do, you want to use brackets to refer to a column of data. So to utilize the value in column 19, then you would put the 19 in brackets. And so maybe if column 20 was kind of the same rating, maybe we took a harvest, once a week we harvested strawberries, and so we wanted to get kind of a total across the 4 weeks that we were harvesting or whatever. Then you can just continue to add each data column and just again surround them in brackets. There are also functions that are available. Kind of like in Excel, they have different functions that you can utilize. Really, the best way to do that, or at least to get introduced to that, would be when you're in this box, press the F1 key, and that will bring up the ARM help, which is a feature you can do pretty much any screen of ARM. Press F1 and there'll be a help topic that will explain kind of what you're looking at. But in this case, it will bring up specifically, let me just get my screen to kind of split up here. It will bring up the data transformation formula topic, and will provide the different options of what mathematical symbols you can use, different functions you can enter in. There's data range functions. So we have a whole write-up on a lot of different things you can do. So this is a great reference to kind of get started with what's possible by utilizing that F1 help. Again, that's the quickest way to get there, at least, is when you're in this cell, click F1. And we've seen one of these already, but there's a couple of options when you're defining that transformation. We showed the limit calculated values to positive. Probably not as common when you're using the user formula, but certainly if you are doing something relative to the check or relative to a reference treatment, anything like that, there's the chance that maybe it ends up being a negative value that doesn't really make sense. So that's really about the only time I think this option would be used, where you really almost truncate the calculation. Anything that's negative should actually just be a 0. Another option here, if you're working with subsamples, is to calculate just one value per plot if subsamples are present. So that's a nice, useful feature. Let me show what I have here in this example. So my calculation here is the second transformation I've defined. So ARM just puts a T2 in the action code, but then within memory, it knows what I actually typed. And so if I go to tools and transform, it will show me what calculation I actually chose. And in this case, I simply took the values in column 19 and multiplied it by 2. Super simple, just to demonstrate what happens. And so you can see, since I have subsample values in the source column, then I have subsamples. It just really does the multiplication right across. If I turn this option on, you'll see it actually adds an ampersand ahead of the calculation. So it's going to calculate just one value per subsample. And I'm going to say, yes, I want to overwrite my calculation. And now I want to set my subsamples. I have one subsample now, and you can see that we have just one value for the 5 subsamples that we had. And so it took the plot average and then multiplied it by 2, or whatever other calculation that we may have done. In this case, it is just simply took the plot average. So this one is very easy. It's a 2. And so we multiplied it by 2 to give us our calculation of 4. So a lot of utility in working with subsamples. If these subsamples were something like a yield, where you would actually want to, you really wouldn't want the average of the subsamples, but you really would want the total to be used, then there is an action code called subsum. And so that changes the default behavior of ARM for this column, so that anytime we summarize subsamples, which is exactly what we did in column 20, is we, now I goofed up my sort. Let me close this. Exactly what we did here is we summarize the subsamples down to one value, the average, and then we used it in the calculation. If I turn on subsum, then ARM will actually take the sum of your subsamples, and that's the value that it uses in the calculation. So now if I do a tools and recalc transformations, now our calculation is different. It added up the total here, and then did the multiplication out. Couple of questions here that came in. First one is if there are unknown formulas that you may see in SE files. So typically, if it's a T something that you would load in an SE, of course you get several. You could have more than one data column come in, and some SEs have transformations. If you click into the column and do a tools transform, it will show you the calculation. There may be some other formulas involved. Just off the top of my head, if they had something, I don't remember, it was like an I10 or something. I've seen some cases where within the calculation there is some data function. So again, we had saw in the help topic, there's some data functions like an add average or an add count. There's these different functions. There's an add in. There may be some kind of customized, I guess we call it here, user-defined transformations, kind of a legacy calculations from sponsors that used to have their own customizations, or maybe still do have a customization, and so it's a calculation from one of those other customizations. It's possible that you, oh, there's an example provided, that at SCB, perfect. So yeah, something like that, SCB. The first thing I would do is just check in the help that we just showed, or in the general action codes. So I would open up my list. I would just do a filter for on the action codes to see SCB. Does ARM have SCB in this list somewhere? And it does not. So in that case, it's likely kind of a transformation probably used in a previous or current customization. And I would just say maybe send us an email and we can kind of look it up. Right offhand, I don't think that some of those are documented. I think we would be able to find, kind of get a programmer to help us dig up and see how that's calculated. And I would say it wouldn't surprise me if you're utilizing the master list of SEs. So if you're in the SE definitions here, I've actually done one already. If you utilize that master list of SEs, this list actually came from a global sponsor, and they used to have their own customization. So there might be some kind of hidden little treats in there like that SCB. I'll maybe look that one up for you and just see if we can track down what that does for you. But great question. Great question. There might just be some hidden gems there in ARM that are, I'll call them legacy calculations, might be a good term for that. Another question that is a very good one to bring up about this user formula. The tools transform menu item is unfortunately disabled in a protocol. So the question was, is it possible to create a user formula in a protocol? And right now, the answer is no. I think the logic is you're in a protocol, there is no data, so we really can't create a calculation. I would say, personally, I could see that you could make a case for re-enabling that in a protocol, so that way a protocol writer could plan out calculations that they would want to utilize. But currently the answer is no, you can't create a user formula in a protocol. What you can do, and kind of the recommended approach then, would be to create your calculation in a trial. So for example, let's see, we were just at form here. So like our T2, let's just say this is really important. We want to utilize this calculation. So in the trial, I have it working. I have it in memory as, this column 19 times 2. Then create an SE. So I would export an SE for, I probably have something goofy stuck here, but create an SE for at least this column. Maybe both of these columns together would make a lot of sense. You want how they enter the data and then the calculation. Create an SE, and ARM will store, make sure to choose your ARM action codes row in the SE, and it will store that transformation in that SE. And then you can load that in a protocol. So that's kind of the workaround, kind of the way to hack a transformation into a protocol would be to define it in a trial, create an SE, and then load that SE in a protocol. So that's a really great question. It's a little convoluted to get the transfer formula. You certainly can utilize any of these action codes. So in a protocol, you can pick any of these built-in chosen action codes. We were using all of those Abbott's or the EPO scales. All of those are nice and easy to bring into a protocol. It's just that user transformation, excuse me, that takes a little bit of hacking. Then when choosing an existing SE file that has a formula, would it be possible to delete the ARM codes if there are any currently? So would that be when we are looking in the SE definitions, you would want to delete the action code? So in the SE definition here, It's really not editable because we really don't want to change the SE itself. You can add additional information. So, if I wanted to add my pest for this trial, you can add some more into this SE definitions, but you can't take away or adjust something that's already in the SE. You could adjust it once you've added it to the editor. So if I load in, let me clear my view here. So I have all of my data columns now. Let's go to the end. And SE name. So I can load my SE. Then when I load that SE, now everything is copied here, and then you could delete the action code or adjust whatever you needed to. Just depends on maybe which action code you're referring to. You want to be careful. Of course, the goal of the SE is that you're documenting the same thing the same way. So now if you're changing things, that might make me a little nervous. It just depends on what you're changing though. It could be an action code if it's like an EC or something where it's not so much changing what you're doing or changing the calculation. That might be okay. Otherwise, if you really are kind of changing what is being done, I would load the SE, make your change you want, and then export the SE. And even if you just export over the top to overwrite your SE, then you can save those changes that you want to make. So that's what I would say is you would changes like that. You're really referring to changing your SE file itself. And so I think you would just basically want to resave that SE with that change you're requesting. And then in that case, you do this once to make your adjustment. Let me just cancel. I don't need to actually do that change, but make your change and resave that SE. And then when you have it on your SE definitions, now that change is made. There won't be an action code once you load that again, and you can utilize that. Great questions, and a little sneak into the SE world a little bit, but those are great. If you see some of these items in the master list, we really encourage you to use them, but definitely change them if you want. So load them up and make whatever tweaks to how you would want to do that, and then save it and give it your own name, but definitely utilize that standardization. That's a great approach. Definitely this master list isn't meant to be a dictionary of the absolute right and only way to do anything. Really suggestions and things you can build upon. So it might be a nice way to help kickstart your own SE library, but customize them to the way you do them. So great questions. All right, well, I've run a little over time. Thanks so much for those questions. I can hang on the line here if there are some more questions, so don't feel again going to cut anyone off if there are more questions, but to be respectful of people's time, I just want to thank everyone for joining us today, and hopefully we'll maybe be seeing you at a future webinar. Send us any questions. If you have some follow-ups once you get into your own trial and trying to do some of this, feel free to let us know if you have any hiccups. So thanks again. I'll hang on here for another minute or two if people are typing up questions. I don't want to cut anyone off, but I appreciate your time and your questions here discussing this topic. So thanks, everybody. Question here about saving a formula template with a prompt. Yeah, so I do have and one more slide if we had time, and not surprisingly, we ran out of some more advanced things you can do with formulas. And so I think if I'm understanding, you would like to prompt the user when you apply that transformation, actually ask for some input. Here, my example was you put in this prompt, and when they apply that transformation, ARM will pop up and say, please enter a value of the crop per yield unit. So in this case, we want to know what the yield was for whatever crop it was. I think this was an example I stole from a yield conversion calculation. But the key is that you use this @ prompt in your transformation, and then whatever text you put in within the parentheses is the text that shows up on the screen that ARM will ask you. So if I take just a really simple example, we can use kind of our transformation where we're just taking some sort of data. We're using column 19, right? So if I'll even adjust this one. So tools, transform. So maybe instead of this multiplier of ×2, I want to ask the user, what multiplier do you want to use? I would just use @ prompt, and then whatever text we want to put on the screen, we'll say, enter your custom multiplier in this case, since that's really all we're doing. So now I said, okay, I applied this transformation. And so putting that transformation into place, now this prompt occurs. And again, this was the text I put in my prompt. And now it says enter your custom multiplier. So now let's change it from 2 to 3. I'll hand enter 3 in. And now you can see, since we put it in place, everything just updated, but we actually hard coded then the number that the user inputted, and that gets saved into the transformation when we used that here in the trial. So just once more, so unfortunately, the prompt we can't use to choose the column number. That one, I think you can use the question mark. That one might be a good time for, I might dig into that one a little bit. And when you're starting to craft SEs, there's some sneaky fancy things you can do with that. I'd have to play around a little bit with a couple SE files to see, but I almost think instead of like the 19 here, I don't remember if it's a question mark. There's kind of some little hack in the SE file then that ARM will kind of tell ARM to do that. But that's something I haven't done personally a whole lot, so I'd probably have to play around with it a little bit before having tons of confidence of of those instructions. So great question. So thanks, everybody.